Good evening, everyone. I'm happy to see everyone here, and I thank ELCINA for providing this opportunity. I am Sarin Sundar. I am the new CTO, Equipment and R&D for the India Semiconductor Mission, especially Semicon 2.0. And last week we met Rajiv Goelji and also a few others from ELCINA in our office. And as you know, the Semicon 2.0 was just recently approved by the cabinet, and I'd say the full scheme details are yet to come. It will come very soon within the matter of few days or weeks, I would say, much before the actual Semicon 2026 exhibition that will happen. I'll quickly show in this presentation about the Semicon 1.0 and the current status of Semicon 1.0, and also the Semicon 2.0 and the 6 pillars. And I'll also talk about how it will fit into the sensor another ecosystem, and also what we are planning to do for deepening the ecosystem. And I'll also touch upon about what's new and what's next worldwide, what is happening. There are tremendous things happening in the world. And also on about the strategic electronics part, what the proposed model, but this is not official strategic electronics part, but what is the US doing, for example, the trusted foundry that was mentioned, and the many challenges that was talked about the speakers before me. So if you look at the overall snapshot of Semicon 1.0 and 2.0, the total outlay is close to $8 billion from ISM. But then in addition to ISM, there are also other agencies who are funding, and also, but the actual committed investment by the technology partners and companies are close to $18 billion. And today, if you look at Semicon 1.0, is a small letter Semicon. The capital letter Semicon is the actual event, and it is equivalent to the European Chips Act or the US Chips Act, and there the funding is slightly larger, but we have a success stories that I will show you here. And the Semicon 2.0 is about $13.2 billion, and we have 6 pillars: the design of chips, equipment, R&D, setting up of more fabs, more OSAT, and also deepening the complete ecosystem. The whole idea is deepening the complete ecosystem, and also including skilling. In addition to ISM, several states have announced incentives by on the capex. So this makes a huge difference, because if you look at other Chips Act in other countries, in India we have plus 50%, plus almost 25 to 30% from the several states. Almost 80% pari passu funding is being provided for many of these projects. And in fact, in Europe, it is, I think, Germany and all gives only 50%, and they also take equity. So in 1.0, we did not take any equity in those companies. And these are the approved projects currently ongoing on various phases. I think 4 of them are actually started commercial production. And we delivered on all the promises that was made on Semicon 1.0. So we got 3 fabs, 1 silicon fab, 1 silicon carbide, and 1 gallium nitride. But gallium nitride is for display, right? And also the rest are the ATMP and OSAT. And the Micron is one of the biggest ones making memory. So, and some of this fabs construction will come on. I'll also show on the timelines. And also look at the status. There's a current status, and as you see, there's a number of wafer starts per hour. So unlike the sensors, the actual commercial fabs, which goes on logic and memory, they do something like millions of chips per month, right? So typically the equipment and the fabs that are being set up will run about 100 wafers per hour. So if you want, say, 1 wafer will have itself around 500 to 1,000 chips, right? So the volume will also depend on what kind of factory that we want to set up. So typically for the strategic electronics side, mostly we call it pilot lines, not full-fledged mega fabs, but most like pilot lines, and which are capable to produce a necessary requirement. But then we also have how to get control of the security aspect. I will just discuss on one slide. And this is again the status of approved projects for the remaining 6 of them. And the number at the bottom shows how many chips, millions of chips per year they will manufacture when they are fully commissioned. And in addition to that, we also have the design link incentive scheme, and we have about many design companies which are designing critical chips. So 24 design companies were approved by ISM. And the interesting part was, after ISM vetted these companies, private equity venture funds invested about $1 billion on these companies. And they are telling us that again another $1 billion will be invested this year on these companies. And some of these companies are also making strategic electronic chips which will be taped out. And we are also rolled out that, considering that in the ISM 2.0. And skilling initiatives. So there's a very, very large skilling. These are all ISM 1.0. We have a chip to startup ecosystem. We have a new semiconductor curriculum which was not there for several decades. Now most of the universities have approved semiconductor and quantum technology courses. And we have big multinationals coming up on, with LAM research, and with MIT and ISM, they have a Semiverse software rolled out, and Future Skills, India AI Skills program. And overall, if you see, not just in India, we are also seeing the news. So we are, government is signing many MOUs on critical technologies with many governments. The snapshot of the recent MOUs signed with various governments, and even companies like ASML recently signed MOU to develop certain systems for their deep UV technologies in India, which was, they didn't have an office before. Now they'll be setting it up soon. And apart from that, multinational companies, the big ones who are doing the equipment sector and also R&D and semiconductor sector, also promised and also started building their own capability. And huge investments are being planned right now. But all this happened in Semicon 1.0. In 2.0, I'll talk about the 6 pillars, and then the government is committed for a long term. So we are officially saying that it will be a 20-25-year-old long program, and then we'll have more semiconductor fabs, more display fabs, OLED, LCD fabs. These are the wish lists. We have the budget allocated for it. Advanced packaging, that is one of the key criteria. And also equipment, and not only equipment, but not only the big players, also the, say, tier 1, 2, 3 supply chain companies, and also materials, the critical, the critical materials part, the chemicals, gases, semiconductor grade materials. So here on the design of chips, first time strategic sector is included. The Semicon 1.0 strategic sectors was not there. So basically here government also now said that we will also take an equity, but government will not take a, so ISM will not take a position on the board because they don't want to influence their operation, but private, whatever the private venture capital companies are investing, equal amount will be invested by ISM. But then the strategy is to make sure that they make the product out quickly. And then the equipment and materials, you can also see that various kind of extremely critical semiconductor equipment. And there will be a PLI for sourcing inputs, and also financial support up to 30% on pari passu basis. And chemicals, gases and materials. These are, again, many companies have now started building up plans for making semiconductor grade, ultra high purity grade materials in India. And pillar 3 and 4, as I mentioned, more fabs, logic and memory, and also display, and also compound semiconductor fabs. We are open to everything. And also ATMP and OSAT and heterogeneous integration 2D. So we know where the world is moving. I'll show you probably one slide on it. And then pillar 5 and 6 is the R&D. When we say R&D, it is industrial R&D, industry-led R&D, and then we are open to collaboration with both inside India and also outside India, and up to 75% from state from center combined. And also we will also leverage the Indian ecosystem. So we have R&D labs in India in the academic sector, in the say national labs. We have CSIR national labs, DRDO national labs, DSC national labs, MIT national labs. There are multiple R&D pilot fabs, about 25 fabs in the country in different stages. And pillar 6 is talent development. This is ecosystem skilling. Complete right from advanced curriculum for the packaging sector, and also, and here also the state plus center incentive is close to 75%. So these are all the categories. And I will quickly, so my time is up, can I take a few more minutes? So I want to cover quickly what's new, what's next for the Angstrom era. So this is something very important, because we also need to understand where the world is playing, right? So if you look at what is going to happen for the next, say, 3 or 4 years, 2030, so these are the major drivers, right? The semiconductor market, but these numbers are now, say, overtaken. Already we have achieved it this year. So this slide is again 2 years old when I was in applied materials, and this was like, we said that $8 trillion of the data centers will be built. You know, Stargate is being built, several AI data centers are being built. In India also we have data centers planned to be built. And we have edge AI and IoT, which will take about 2 trillion. And EV and autonomous vehicles, another 1.5 trillion. And it's renewable energy, whether it be solar. And so all the semiconductors used in these are supposed to be the biggest inflection. So it's a multi-billion dollar. So trillion is like 1,000 billion. So we are talking about extremely large industries. But what actually happened is very, very different. So this is what practically happened. So if you look at this chart, we already reached $1 trillion of semiconductor industry in 2026, which was supposed to happen in 2030. You know how the memory prices increased, and this is scary because if you look at the start of this graph, the x-axis, so 1980s or 70s, that's when the whole world, everything started becoming computerized. Your banks, your airplanes, your railways, your finance system and everything. Maybe the IBM mainframe era and then your PC and internet era. So whatever happened in the last 60, 70 years is happening now in the new 2 years or 3 years. And we just say about 2 years ago, the whole semiconductor industry revenue was about $500 billion. 2026, we are 1 trillion. 2030, we are 1.6 trillion, right? Which means many companies, new companies will grow. You know, each of these PC era or mobility era, new companies came and became very big, right? So, you know, one announcement from Cloud, Mythos or something is rattling the market. So, a lot of tremendous amount of things are happening across the world and will continue to do. And I'll also told you a brief glimpse of what is happening. So, before that, I'll also show a manufacturing roadmap. This is the manufacturing roadmap I've taken from TSMC. You know, it's the world's best manufacturing semiconductor industry and where we are with respect to Semicon 1.0 and 2.0. So, we had, say, 180 nanometer, 0.18 micron fab, so our SEL, and then that is before Semicon 1.0. That's the first line that you see. And after Semicon 1.0, so we started the Tata fab, which will be producing, say, 90 nanometers to 28 nanometers. The actual chips will be commercially will be available sometime between 2028 and 2029 because a fab of that scale requires almost 4 to 5 years to build. And we are not building alone. Today, more than 146 fabs are being built all over the world. Under the same supply chain, same equipment companies are also involved. And there are a lot, and we are building it for the first time. So we need to have the complete talent and everything. And in the Semicon 2.0, we are probably looking at below 28 nanometer also. We are open to proposal and there are some which will be coming. And on the R&D roadmap, so this is a, say, R&D roadmap from IMEC. And this is actually from a couple of years back. I'll show you what is the R&D roadmap today. So if you look at the R&D roadmap, for the semiconductor industry, the roadmap is defined till 2041. Right? Till 2041, what kind of chips will be coming, whether it is CFET, whether it is backside power delivery. So, and then the industries always work with them. But then this all changed last month when IBM announced a 7 angstrom. So we still talk about, say, microns and, say, tens or hundreds of microns for the, say, electronics part. But then now we are in the angstrom era officially. And as we speak, 2 nanometers or 18 angstrom is in full production. You won't get a laptop of 2 nanometer in the market right now, but it will come towards the end of 2026. And IBM 7 angstrom roadmap basically extended it up to 2050. And also compressed because for the long time, for the last about 12 years, the memory inside the logic chip, the SRAM, hit a memory wall. They couldn't shrink it for the last 12 years. For the first time, IBM showed how to shrink it, right? Which means your AI accelerators, everything will change. And then the companies are also now thinking of new ways of, say, making R&Ds, like PPAC and PPAC-E and XTCO. These are the new terms our R&D institutions have to work together. So the FinFET era is moved to gate-all-around and also to CFET, right? So on the sensors part, we will be still on planar side and also. And then we also have physical AI. Today, we are in the world of physical AI. Basically, what it means is your AI is out of your computer screen and internet. So we have humanoids, animaloids. We have seen commercially, they are commercially available, right? And these are examples of where robots are working in factories. So many automotive companies have put them in. And in fact, end of June, there is a 1,000 robo continuously working for 6 days was live streamed by a Chinese factory. And they have 99% accuracy of making those tablets, right? So physical AI is real and it is here. We have robotic humanoids, robotic animaloids, and you could have seen these little dogs, and also for military transportation, they also have robotic horses, and also different kinds of humanoids. And these physical AI has much more challenges. For example, they need AI accelerators. Today's AI accelerators is a sample about 2024, about 1 or 2 years back. These are all like, say, 4 nanometer technology. And it requires huge amount of, and this is the shift that is now driving the memory industry, because each of these AI accelerators requires huge amount of memory, right? And if you look at very closely, Google TPU4 is there, the tensor processing unit. From TPU3, the chip itself is designed by AI, right? So this is something very different things are happening today. So I wanted to show you where we are when we are planning, and also looking at how we want to see what kind of sensors or fab that we are going to set up. And also physical AI, as I said, it's outside the screen. And LLM. So sir mentioned about, say, attention is all you need, the greatest papers. So if you look at ChatGPT and LLM, as of June 2026, ChatGPT is 8 years old. LLM is 9 years old, right? Today, we are no longer in that regime. We are now in a world where large language model, any of your ChatGPT is one software which can do it all. So there was a days earlier where every, domain had its own software. We had PowerPoints, Word, we had Python, we had electronic design softwares. Today, you can go to ChatGPT and do everything, right? You can do presentation, you can ask it to do chip design. Last week, China open sourced Kimi K3. If you have looked at it, Kimi K3, you just make a prompt, it designs a 45 nanometer chip in 48 hours. Of course, you need to do physical verification. So it's changing. The industry is tremendously changing. We should be aware of it when we make our plans. And then looking at strategic electronics, I just have one slide. So already I have taken too much time. So of course, many things were covered. So we look at what happened in the US, right? This is something called Trusted Foundry. So this has right from Trusted Foundry is having zero trust in from the design phase and the silicon phase, and it was originally started with IBM, and then eventually when IBM closed the factories, now with the Global Foundries is the main leader. So today there are 81 partners they have at various levels, right from making the modules and also validation. So the Trusted Foundry model is something that is very suitable for our strategic electronics. That is something that we should also look into. And this is led by the Department of War in the US. And of course, the sensors part, I will probably take much more longer time to cover, but I thank you, and I'll also take any questions later on after the panel is done. Sorry I've taken more time. So thank you very much.